Have you ever had a brilliant idea for a gadget, a smart device, or an automated solution, but felt stuck on how to bring it to life? Maybe your garage workbench is a testament to your creativity, a beautiful chaos of wires and components just waiting for the right spark. Perhaps your best ideas are still just sketches on a napkin, concepts for a smarter alarm clock that does more than just beep, or a plant that waters itself. You see a problem and imagine a solution, but the bridge between the two seems complex, expensive, or reserved for seasoned engineers. If any of this sounds familiar, then you're ready to meet Arduino. It's the tool that gets your ideas off the napkin and into the real world. So, what exactly is Arduino? At its heart, Arduino is an open-source electronics platform. Think of it as a small, friendly, and powerful brain for your projects. It's a type of microcontroller board, a miniature computer that you can program to read information from the world around it and then act on that information. Unlike the computer on your desk that runs complex operating systems and multiple programs at once, an Arduino is designed to do one thing at a time and do it exceptionally well. It connects the digital world of code to the physical world of light, sound, and motion. It's the key to making your environment interactive. To really understand its power, let's take a closer look at the board itself. The most prominent feature is the large black chip at its center. This is the microcontroller, the ATmega328P on a classic Arduino Uno. This is the brain of the operation, where your code is stored and executed. To power it up, you have a couple of simple options: a USB port that connects directly to your computer, or a barrel jack for an external power supply, like a battery pack or a wall adapter. The real magic happens along the edges of the board, with the rows of black headers. These are the input and output pins, or I/O pins. On one side, you have the digital pins. These are like simple light switches. They can only be in one of two states: on or off, high or low, 5 volts or 0 volts. You use these to read from a simple button, or to turn an LED on and off. You'll notice some of these digital pins have a little squiggly line, or tilde, next to them. These are special pins that support pulse width modulation, or PWM. This is a clever technique that lets the Arduino fake an analog signal, allowing you to do things like dim an LED smoothly or control the speed of a motor, instead of just turning it on and off. On the other side, you'll find the analog input pins. Unlike their digital cousins, these pins can read a range of values. They can detect varying levels of voltage, which is perfect for reading sensors that measure things like temperature, light intensity, or the position of a knob. An Arduino Uno can distinguish between 1,024 different levels, giving you a nice resolution for your sensor data. The board also includes dedicated pins for communication protocols like I2C and SPI, which allow your Arduino to talk to more complex sensors and modules using just a few wires. And don't forget the tiny onboard LED connected to pin 13. It's perfect for a quick test to make sure your first program is working. So, how does it all work together? It follows a simple but powerful three-step process: input, process, and output. First, the Arduino receives an input from a sensor. Let's say you connect a temperature sensor. This sensor constantly measures the room's temperature and sends that information to one of the Arduino's analog input pins as a varying voltage. Next, the Arduino's brain, the microcontroller, will process that information. It runs the code you wrote and uploaded to it. Your code might say, if the temperature reading goes above 25 degrees Celsius. Finally, the Arduino creates an output. Following your code's instructions, it sends a signal from one of its digital output pins to an actuator, in this case, a small fan. The fan turns on, cooling the room. When the temperature drops back below 25 degrees, the sensor sends a new input, the Arduino processes it, and it turns the fan off. Input, process, output. This simple loop is the foundation of almost every electronics project you can imagine. This brings us to the process part of the equation: programming. If the word coding seems intimidating, Arduino is here to change your mind. You write your programs, called sketches, in a free application called the Arduino IDE, or Integrated Development Environment. The language is a simplified version of C++, but it's designed to be incredibly beginner-friendly. Every Arduino sketch has two essential parts. The first is the function. This is your preparation block. The code inside runs only once, right when your Arduino board powers on. Here, you'll tell the Arduino which pins you're using as inputs and which are outputs. The second part is the function. As the name suggests, the code inside this block runs over and over and over again, forever, as long as the board has power. This is where the main logic of your project lives: reading sensors, making decisions, and controlling actuators. It's the heart of the input-process-output cycle, and you're never starting from scratch. Arduino has a massive collection of libraries, pre-written packages of code that make it easy to control complex components like LCD screens, motors, and sensors. Instead of writing hundreds of lines of code to control a servo motor, you can simply include the servo library and use simple commands like to move it to a 90-degree angle. The IDE also includes a vital tool for debugging: the serial monitor. This is a simple text window that lets your Arduino send messages back to your computer. You can use it to print out sensor values, check the status of your program, or track down bugs, making the development process much smoother. So, what can you actually build with all this? The possibilities are truly limited only by your imagination. You can build robots that follow lines or avoid obstacles. You can create interactive art installations with lights that dance to music. You can design a custom alarm system for your home, or a smart weather station that logs data and displays forecasts. Home automation becomes accessible. Control your lights, blinds, and appliances with your own custom system. It's also the perfect entry point into the exciting world of the Internet of Things, or IoT, creating devices that connect to the web to send data or receive commands. It's important to understand how an Arduino differs from a regular computer or even a single board computer like a Raspberry Pi. A PC is a multitasking beast, running a heavy operating system, juggling dozens of processes, and consuming significant power. An Arduino is a specialist. It runs a single program in a continuous loop, has no operating system, and is incredibly power efficient, making it perfect for battery-powered projects that need to run for days or weeks. It excels at real-time control, reacting instantly to inputs without the lag of a complex OS. So, who should learn Arduino? The answer is almost anyone with a curious mind. It's an invaluable tool for students learning about electronics and programming, providing a hands-on way to see code come to life. It's a paradise for hobbyists, makers, and tinkerers who want to build custom gadgets. It's a fantastic resource for artists who want to add interactivity to their creations. And it's an essential skill for anyone aspiring to work in robotics, IoT, or embedded systems. Getting started is easier than ever. All you need is an Arduino board. The Uno is a fantastic first choice. A USB cable to connect it to your computer, and a starter kit. These kits are brilliant value, typically including a breadboard for solder-free prototyping, jumper wires, and a variety of fun components like LEDs, buttons, sensors, and motors to experiment with. The best part is the incredible global community. There are millions of users sharing their projects, writing tutorials, and answering questions on forums. The official Arduino website is packed with examples and documentation. Whatever you want to build, chances are someone has built something similar and shared their code and instructions. You rarely have to start from a blank page. Prototyping becomes a fast, iterative, and fun process of learning and discovery. Arduino closes the gap between imagination and creation. It's more than just a piece of hardware. It's a key that unlocks a world of interactive possibilities. So, that idea on your napkin? It's time to pick up a board, plug it in, and make something amazing. Ready to start building?